Welcome to our first discussion on simple algebraic equations. So we're going to solve two different kinds of equations today. The first one is going to look like x plus a number equals another number. So let's start with an equation. Let's say we have x plus a number, let's say 2, equals 7. And we want to find out what number or what value x is. So that means we need to get x all by itself. Well, before we do any algebra or before we go too far into explaining this, we could just think about this. This is a simple enough equation. We could probably figure this one out in our head. If we thought about our addition facts, we thought, well, what number plus 2 equals 7? Well, 4 plus 2 is 6. 5 plus 2 is 7. So if we just think about it, put a little thought cloud there, we have x equals 5. That's just thinking about it. So we have x equals 5. Okay, now that works well enough if we have simple equations like this. But it's not going to help us if we have more complicated algebra expressions. So it will be good if we can think of a way that approaches this solution more systematically and more generally. So let's think about this in another way before we do the algebra. I like to think of it in terms of a seesaw or a scale. So we have a seesaw. Bear with me. I know that doesn't look like much of a seesaw, but that's a seesaw, and it's in balance right now. Nobody's on it. But we're going to try to think of this equation, though, as a seesaw in balance, and on the left-hand side of the equal sign, we have one value or one expression. And on the other hand, on the other side of the equation, or the equal sign, we have this number 7. So these objects, or these things, are actually in balance. We have x on the left, plus, and we have, let's say, 2 objects, equals, or is in balance with, 7 objects on the right-hand side. So we have 1, 2, 3, 4, 5, 6, 7. So we have x plus 2 things equals 7 things. And this is in balance. But we want to get x all by itself. So in order to keep this seesaw in balance, if we try to get x all by itself, that means we need to somehow figure out how to get rid of these two off this side of the seesaw and keep the seesaw in balance. So if we remove one person or one object from this side of the seesaw, we need to remove one on this side in order to keep it in balance. Otherwise, it gets heavier on one side and starts to get out of balance. And if we want to remove another object or another person, then we need to remove one on the right-hand side to keep it in balance. So what we're left with on the left-hand side is x off, and that's exactly what we want. Let's bring that plus sign back. And so on the right-hand side, what we have left are these 1, 2, 3, 4, 5 objects. So we have 5 objects here on the right. So that gives us x on the left and 5 objects. And those 5 objects we could just say equals 5. So in this case, we thought of a seesaw, kept it in balance by removing the same number of things on the left as we did on the right, and we ended up with 5. X equals 5. That's in agreement with what we thought in the beginning. Okay, now that's all well and good, but it can become tricky if we want to draw a seesaw for every single problem we're working on. It takes a little bit of time. So we'd like to have a slightly more algebraic way to do things. Mathematicians can be, I wouldn't say lazy, but they like to be efficient. They like to do things that require less time. So let's think about this in a way that might help us do it in less time. So we have x plus 2 equals 7. That's our original. And now instead of having 2 objects, we just have the number 2. And instead of writing 7 objects, we just have the number 7. We're not using our seesaw. But we want to think about this still in the same way of it being balanced. If I have x plus 2 equals 7, I want to just have x all by itself, which means I need to get rid of this 2 somehow by taking away 2 on the left. But if I take away 2 on the left, to keep it in balance, I need to take away 2 on the right. And so if the 2 plus 2 and the minus 2, they actually cancel out. And what we have left all by itself is x. And that's exactly what we're going for here. So we want to get x all by itself. And now on the right hand side we have 7 minus 2. 7 minus 2 is 5. And that's exactly what we got in our first two approaches. So the only thing that we have left, and it's usually good to do this, I know sometimes it takes a little extra time and you think you got your answer right, so why bother going any further? But it is important to check your answer, especially in the beginning before you've had a lot of practice. And the way you check your answer is you plug in the number you get, your answer, you plug in x equals 5 into the original equation. So in your original equation, let's change colors just to make it interesting. We have x plus 2 equals 7. And we want to see if our choice or our solution for x works. So we're going to plug in 5 into our value for x, or as our value for x, then plus 2. Is that equal to 7? Is 5 plus 2 equal to 7? Yes, it is. So this answer checks. So 5 does work. Even our thought cloud is working. Okay, so let's do another similar example. We won't go through the seesaw exercise, but we will use our thought cloud. Let's say x minus 2 equals 7. So how do we think about this one? Instead of having x plus 2 equals 7, we have x minus 2 equals 7. So what number, if we take away 2, gives us 7? Well, let's try 7 minus 2 is 5. 8 minus 2 is 6. 9 minus 2 is 7. So thinking about it, we have x equal 9. But again, thinking about it is helpful, especially in the beginning if we have a simple equation, but it can become very complicated as the expressions or the equations get more difficult. So let's use our algebra tools now that we just visited in our first example. If we have x minus 2, remember we want to think of this as something in balance, like a seesaw. We won't draw the seesaw though, you can remember it over here. And we want to get x all by itself. So we have something on this whole left side is in balance with this entire right side. So the left side is balanced with the right side. So what's on the left hand side? X minus 2. Well, we want to get x all by itself. In order to do that, we need to cancel out this minus 2. Well, how do you cancel a minus 2? Well, we can add 2. But if we add 2 people on this side of the seesaw, if you will, in order to keep it in balance, you need to add 2 people or 2 objects on the right to keep that in balance. So this minus 2 and the plus 2 cancel out. And so what we're left with on the left-hand side is x. And 7 plus 2 is 9. So we have x equals 9. So now, remember, we want to check our work. So in order to check our work, we just want to substitute x equals 9. Do a check. We're going to substitute x equals 9 into our original expression. And our original expression is 9 minus 2 is 7. 9 minus 2 is 7. 7 plus 2 is 9. 9 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 plus 2 x minus 2 equals 7. So we want to see, does our solution for x equal 9 make this equation true? So let's go and substitute. I'll use red just to change it up a little bit. Is 9 minus 2, is that equal to 7? Well, 9 minus 2 is in fact 7, so this checks. So x is equal to 9, and our thought cloud for x equal 9 works. So what we've done in this example, or these two examples, is we've shown how to solve an equation of the form x plus a number equals some other number. And in our second, that's an M, sorry, it's tricky to write sometimes. And our other example was in the form of x minus a number equals a number. So in our next presentation, I'll talk about x times a number equals a number, and x divided by a number equals a number. But for now, this covers it. Thank you.